Welcome to this Maths Made Easy video on exponentials and logarithms. To start with, let's discuss the idea that logarithms are the inverse of exponentials. So let's just introduce the notation that we use here for a logarithm. So to start with, we denote logarithms as log of say b here, and this little letter or number underneath represents the base. So here, this is the logarithm of b base a, okay, and this, let's just say, is equal to c. Now what this represents here is a to the power of c is equal to b there, okay. Now using some basic rules of indices, such as a to the power of 1 is always equal to a, in that case the logarithm of a base a is equal to 1, okay. And again, another basic rule of indices here, a to the power of 0 will always be equal to 1 there for all values of a. So in that case, if we take the logarithm of 1 base a, this will simply be equal to 0 there. Now let's just take a look at a brief example here. So if we've got the logarithm of 81 and our base is 3, so this is log 81 base 3, take a moment now just to think about what this would be equal to in value. And hopefully you can work out that this is equal to 4. And the reason for that is because 3 to the power of 4 is equal to 81. Now there's some rules that we need to be aware of when working with logarithms. And let's give each of these rules or laws in different colours. So the first law here is the logarithm of x base a plus the logarithm of y base a is equal to a single logarithm here, and here we write this as a product. So if we're adding log x base a plus log y base a together, then we can write that as the product here. So it's the logarithm of xy base a. So notice the base here is the same as what we started with here. So the next law that we need to be aware of is log x base a minus log y base a is equal to the logarithm, and again expressing this now as a single logarithm, x over y, and again base a there. The next law here, so log of xn, x to the power of n base a, well this is simply equal now, we can apply the power rule here and we can bring this n down in front of the logarithm. So this gives us n log x base a there, okay. And the final law that we need to be aware of here, and again let's get this in a final pen colour here, is the change of base law. So here this is log x base a, and we can express this as log x base b all over log a base b there, okay. So finally, let's just make a closing comment here that the most common base is base 10. However, this is usually omitted. So for example, for log 10, we would just write this as log, okay. So that gives everything we need there for logarithms being the inverse of exponentials. Moving on now to take a look at using logarithms and exponentials to solve equations. So we have two examples here. We have 3 to the 4x equals 5, and we have 6 log x base 4 is equal to 17. So to start with, let's take a look at this example here, which we'll cover in blue pen. Now, for this example here, all we're going to do to start with is just take the logarithm of the left-hand side and the right-hand side. So here, we obtain the log of 3 to the power of 4x, and this is equal to log 5. Now here, if we don't give the base, we'll just assume we're working in base 10. However, for this example, it actually wouldn't matter what base we take here. So, again, using the laws of logarithms that we just previously defined here, I can use the power rule here. So this 3 to the 4x, remember we've got the logarithm here, we can bring this 4x to the front of the logarithm. So this gives us 4x log 3, and this is equal to log Now here, what we want is simply x. That's what we're looking to solve here. So in that case, if I just want x, all I've simply got to do here is divide by 4 log 3. So therefore, x is equal to log 5 divided by 4 log 3 there. Okay, and all we need to do now is evaluate this on our calculator, and what we obtain here is 0.366 there. Okay, and that gives us the value of x. And let's take a look at the second example here now, and again, let's do this in a different pen colour. So what we've got here is 6 log x base 4 is equal to 17. Well, the first thing we want to do here is get rid of this 6 at the front, okay? And to do that, we just do the opposite. So because we're timesing by 6 here, we just divide by 6. So in that case, obtain log x base 4 is equal to 17 over 6, okay? Now here, as this is log x base 4, we need to use the fact that we're working here with base 4. So to obtain x here, what I'd obtain then is just x. And this right hand side here, well in that case, don't forget we're working with base 4 here, so that's going to become 4 to the power of 17 over 6 there. Okay. And if you input this into your calculator here to obtain the value of x, you simply obtain 50.8 there. Okay. And that gives us the solution to the second example here, where we're using logarithms and exponentials to solve equations. And finally, moving on now to take a look at graphs of exponentials. Now, an exponential graph is a graph of the function y equals a to the power of x. So y equals a to the power of x. And this is for some a value that's greater than 0. So a greater than 0. And they all have a similar shape. Now, if a is greater than 1, then y increases as x also increases. However, if a is less than 1, then y decreases as x increases. And the larger a is, the faster the increase is for a greater than 1. However, smaller a values give a faster decrease if a is less than 1. It's also important to note here that exponential graphs never reach 0. Okay, so we'll always have an asymptote here with the x-axis. Okay, and what we can see here is two lots of examples. We've got examples here for a greater than 1 and examples here for a less than 1. And for a greater than 1 here, we have 3 exponential graphs. We have y equals 2 to the power of x. We have y equals 3 to the power of x. And finally, we have y equals 4 to the power of x there. Okay. And here, for a being less than 1, again, we've got 3 different exponential graphs. And we've got y equals a half to the power of x. We have y equals a third to the power of x. And finally, we have y equals a quarter to the power of x there. Okay. And that gives us everything we need there for graphs of exponentials. And that concludes this Maths Made Easy video on exponentials and logarithms.